What's going on, guys, and welcome back to the channel. Today we're going to be going through how exactly to do the chain rule when differentiating functions. First off, we need to examine why this is important in the first place. And to do that, I've put a little example on the screen. To take an example, for paper 11 of the October-November 2023 series, roughly 18.75% of the paper had some kind of derivative component attached to it. To make things worse, there are smaller questions that will inevitably drain your time in the exam, which will accumulate, turning that 18.75% into 45% or even 50% of the paper being straight up wrong. What we want to achieve here is very simple, and that's to build a foundation that will allow us to differentiate functions like sine to the power of 3x all the way to solving implicit and differential equations like you see below. This is going to give us a solid foundation and ensure that we're not needlessly losing marks. However, we do have harder questions towards the end of the video, so if you want, you can skip to that bit now. The best way to think about the chain rule is like a Russian doll. There's one big doll, and inside it, there are multiple other dolls that you unpack. And before you know it, you've unpacked all the dolls outside the big doll. Now, finding the derivative is the same. You differentiate the outside function first, then multiply it by the derivative of the inside function. If there's more, you repeat the process. Now, with that in mind, let's get to some examples. Alright guys, so for the first example here, what we've got is a question that wants us to find the line tangent to the graph h of x at x equals 2. Okay, so line tangent to the graph, the first thing that should be going through your head is dy by dx, right? So, I'm going to rewrite h of x as 3x minus 5 to the power of minus 2. And I've done that because this is actually a fraction, right? This is at the bottom, so therefore we can rewrite it like this. And for anything to be a tangent, as I just said, you need to be thinking dy by dx. In this case, h dash of x. Okay, that's going to equal minus 2. I'm going to bring this over. Okay. 3x minus 5, right, to the power of minus 3. I've done the traditional derivative method. But now what do we do? Because remember the Russian doll example. What we've actually got here is one big function and one smaller function over here, right? I'll repeat, one big function, one smaller function here. So, I've taken the 3 down, so I've taken the 2 down, I've minus 1, I'm then going to times by the derivative of 3x minus 5. Okay, so therefore, h dash of x is going to equal minus 2 3x minus 5 times 3, okay, which gives me minus 6 3x minus 5, okay, and that should be to the power of negative 3. So what we've got there is our derivative, okay, h dash of x, but at x equals 2, what do we get? Well, this is going to give us minus 6. Okay. So, the gradient is going to equal minus 6. In general, at x equals 2, h of 2 is going to equal 1. 2 minus 5. Okay. So h of 2 is just going to equal 1. So our point, therefore, is going to equal 2, 1. So we just apply our equation. So we say y minus y1, which is 1, is equal to minus 6. X minus x1, which is 2. Okay, so y minus 1 is equal to minus 6 plus 12. So y is equal to minus 6x plus 13. Okay, and that's going to be the answer to that question. Now we've got an example that says sec 4x to the power 5 plus 2x. So if we have y is equal to sec of 4x to the 5 plus 2x, what do we do here? Well, first we need to identify what is the outer function. That is sec. What is the inner function? That is 4x to the 5 plus 2x. Right? So, what does that mean? Well, what that means is, firstly, what's the derivative of y here? What's dy by dx? Well, dy by dx is going to equal sec x tan x. Okay? Which means that in this example, dy by dx, we're going to have sec 4x to the 5 plus 2x tan 4x to the 5 plus 2x times d dx of the inner function, which is 4x5 plus 2x, okay? Which means we get sec 4x to the 5 plus 2x tan 4x to the 5 plus 2x times 20x plus 2, okay? And if you just want to make it prettier, we can just rearrange this and put the 20x plus 2 at the start there. And this is what your final answer is going to be for that question. Alright guys, now what about in this example? What do we do here? Well, we've got cos to the 4 of 7x squared plus 1. So there's two functions here, right? With the outer function being cos. Wrong. Here, what we've actually got is cos of 7x squared plus 1 to the power of 4. So we don't have two functions, we've got three functions. Okay? We've got the outer function, which is f of x to the power 4. A middle function, which is g of x, and the inner function, which is h of x. Okay, where g of x is cos, f of x is to the power 4, and the inner function is h of x. So here's what we do. We're going to take the 4 down. So we get 4 cos to the power 3 7x squared plus 1. Then we need to do the next bit. And the next bit is to integrate cos. Okay, again referring to this inner function. Integration of cos is going to equal negative sine. So times by negative sine 7x squared plus 1. Now we go even further. We now have to, sorry, not integrate, differentiate. Now we differentiate 7x squared plus 1, which is going to equal 14x. Okay. Brilliant. So, we then add that all together. Okay, so 14 by 4 is negative 56. Sorry, 56, but then you add the minus in, so you get negative 56x sine 7x squared plus 1, cos to the 3, 7x squared plus 1 there as well. Okay, and that's going to be your final answer to that question. Now this is a very important question because this is especially important for those who are in the pure 3 side of things, where you combine the product rule and the chain rule together. Okay, so the way you do that here is to firstly remember what the product rule is. So uv plus uv. Okay, we find the derivative of u, derivative of v, and say let u equal 2x plus 1 to the 5. If you haven't seen the product rule, check out my video on product rule. I'll link it below. Let v equal 3x minus 2 about 7. So u dash, which is the derivative of u, is going to equal 5 2x plus 1. And then, sorry, to the power of 4. Then what's your inner function? Your inner function is 2x plus 1. So you're going to times it by 2. So you've got 10. 2x plus 1 to the 4. Okay. V dash 7. 3x minus 2 to the power 6. But then you've got an inner function. So you need to find the derivative of that. 3, which equals 21. 3x minus 2 to the power 6. Okay. So what we have here then is a situation where we've got 10. So 10 2x plus 1 to the power 4 times 3x minus 2 to the 7, following uv plus uv, u dash v plus uv dash, plus 2x plus 1 to the 5, okay, times 21 3x minus 2 to the 6. Okay. And so from here, we've got a scenario where we can say, okay, look, let's put this all together. So 10, 2x plus 1 to the 4, 3x minus 2 to the 7, 21, 3x minus 2 to the 6, and 2x plus 1 to the 5. Okay. So from here then, we can, this is technically the answer, but we can factorize this to make things simple. We can say that if we take out 2x plus 1 to the 4 and 3x minus 2 to the 6, we've got 10 here. Okay, 10 times 3x minus 2. Okay, plus 21. And you're gonna have, what you're gonna have there is 2x plus 1. Right, so what you get then is 2x plus 1 to the 4, 3x minus 2 to the 6, 30x minus 20 plus 42x plus 21. Okay, so you get then 2x plus 1 to the 4, 3x minus 2 to the 6, times 72x plus 1. Okay, and that's going to be your final answer there. Now here we've got an example of implicit differentiation, and there's not enough content here to make a video on itself. I'll have to make a new video on that, but this really demonstrates the power of chain rule. Okay, so it's very important that you focus here, especially if you're in Pure 3, because this makes a big difference. Okay, and this comes up a lot. So we're going to say this. We're going to find the derivative of each element in this equation. So d dx, okay, x squared plus d dx of y squared is equal to d dx of 25. Okay. Remember, they want dy by dx. So where do we go from here? Well, d dx of x squared is just going to equal 2x. Okay. But what about d dx of y squared? And this is really where the focus is. So really pay attention here, because this is a danger zone. This is where loads of people trip up. So make sure you're not one of them. Here we need to apply the chain rule for this. Okay. We need to apply the chain rule for this, because we've technically got two functions here. We've got the function y, and we've got the function of squared, of something being squared, right? So therefore, if we're finding dy by dx of this, what we're going to do is we're going to say, fine, bring down the 2. We have 2y, and then what's the derivative of y? Well, the derivative of y is dy by dx, okay? And so we get that, and then the derivative of 25 is 0. And so from here, we can take out the 2. So all we're left with is x plus y dy by dx is equal to 0. Sorry, actually I've made a mistake there. That should be even better. What I can say is 2y minus 2x here. The 2 is going to cancel. Okay, so therefore dy by dx is equal to minus x over y. And that's going to be your final answer there. Alright guys, so now we've got a scenario where we've got this equation, x cubed sine y plus y is equal to 4x plus 3, and we have to find dy by dx. So how do we do this? Okay, it's back to implicit differentiation, and again the chain rule as a result. So what I'm going to say is d of dx of x cubed sine y plus d dx of y is equal to d dx of 4x plus d dx of 3. Okay, now what we can do now is just break this into different parts. So let's attack the big one first. That's this over here. So let u equal x cubed, and let v equal sine y. That tells us that u dash is going to equal 3x squared, and v dash, again, if you don't know the product rule, make sure to check out the video linked below. V dash here is going to equal cos y. Okay, cos y, but not just cos y, dy by dx, because we're finding we've got the derivative sine to cos. Now we need to integrate the inner function. That's y and that's dy by dx. So, very simple. If we put this all together, what we get then is 3x squared sine y plus x cubed cos y dy by dx. Okay? So really what we're going to have here is 3x squared sine y plus x cubed cos y dy by dx. Okay. Plus dy by dx. Now why is this? Why have we got this here? We got this because of the y over here. Okay. And that's the, as you saw before, the derivative of y is dy by dx here. That's going to equal 4. Okay. And so from here, what we can say is x cubed cos y dy by dx plus dy by dx is equal to 4 minus 3x squared sine y. Okay, let's take out dy by dx as a common factor. We've got x cubed cos y plus 1 equals to 4 minus 3x squared sine y, which means that dy by dx is equal to 4 minus 3x squared sine y over x cubed cos y plus 1. Okay? And that's going to be your final answer to that question.